In this lesson, we are going to learn about the concept of work done. Now, we've all heard the phrase, do some work. You may have heard it from your teachers or your parents. But what does doing work actually mean? I wasn't entirely sure, so I Googled it, and this is what I got. To be engaged in a physical or mental activity in order to achieve a result. That's what doing work means. Now we could break this definition down into two. To be engaged in a physical or mental activity in order to achieve a result. These are the two components to doing work. Engaging in a physical or mental activity and achieving a result. You could also think of this as simply trying. If someone's trying to do something. Let's look at a few examples and see if the work is actually being done or not. In this case, we have a man trying to lift a car. Is this man engaged in a physical or mental activity? Is he trying to do something? Absolutely, of course he is. He's trying hard. However, is he achieving a result? No, the car isn't moving. The car isn't moving, so he isn't achieving a result. Therefore, is work actually being done in this case? No, work is not being done. Let's look at another example. Here we have Terry Crews lifting a car. Is he engaged in an activity? Yes, he is. In this case, is he achieving a result? Absolutely. He's lifting that car right off the ground. Therefore, is work being done? Absolutely, work is being done. Now let's look at these examples and think, what does this mean in terms of physics? The activity both these men are engaged in is trying to lift this car. They're trying to apply, or they are applying, a force on this car. So the activity they're engaged in is applying force. And if they're achieving a result, it would be moving the car a certain distance. And those are the two criteria for work being done. Those are the two components of work done. Force and distance. Let's look at a few more examples to see if work is being done or not. In this case, we have a man cycling in a race of sorts. Is a force being applied? Absolutely. This man is cycling uphill or maybe in a straight line, but definitely a force is being applied. Is this over a distance? Absolutely. Remember, these are the two criteria, the two components of work done. So is work being done? Absolutely. It's being done. It's also important to think, is energy being transferred? Absolutely, energy is being transferred from the chemical energy within the man's body to kinetic energy. We'll see a pattern between the work done and the energy transferred. What about this case? Is a force being applied? This is almost a trick question. There is force being applied in this case. It is actually a weight. The downward force acting on the car. This can also be thought of as gravitational force. So a force is being applied. Is it being applied over a distance though? As we can see, the car is not moving, so it's not over a distance. Therefore, is work being done? No, work is not being done. And to answer our previous question, is energy transferred in this case? No, there's no energy transferred. You might start to see the pattern now between work done and energy transferred. Let's look at this cat fast asleep. Is force being applied? Similar to our previous example, force is applied, just simply gravitational force. Is this over a distance? Is the cat moving at all? Absolutely not. This cat probably hasn't moved for a couple of hours. Therefore, work is not being done. And therefore, energy is not transferred. Let's look at one final one. Is force applied? It's actually the same force as the force acting on the cat before. Force is being applied. It is gravitational force acting in this direction, pulling these skydivers towards the Earth. Is this over a distance? Absolutely. These people are probably a couple of 100 meters above the ground, and they're falling towards the ground, so this is over a distance. So is work being done? Of course. Work is being done. We can also think, is energy being transferred? Remember, these people are falling from a certain height towards the ground. So we have a transfer of gravitational potential energy to kinetic energy. So energy is being transferred. We should now be able to see the connection. Work done is equal to energy transferred. So let's take this down here. Pause the video and fill in the blanks. And when you're done, can you predict the formula of work done? Now that you've paused the video, let's go about filling this in. Work done. Work is when something is applied on an object which makes it something. So work is when a force is applied on an object which makes it move. Remember, it has to move over a certain distance for work to be done. It also means the transfer of energy. So hopefully you got that right. And if you worked on the challenge question, let's see if you got that right too. So work done can actually be calculated using the formula work is equal to force times distance. Work, or work done, can be represented using the symbol W. Force, as we know, can be represented by F. And distance can be represented by many things, S or X, sometimes even D. In this case, we're going to use D. Distance is measured in meters. Force is measured in newtons. And work is actually measured in joules. So this is the word equation, this is the symbol equation, and these are the units. Remember, meters, spelled like so, newtons, like so, and joules can be a tricky one, spelled like this. However, when you do calculations, you must always use the symbols at the end of your values. It's not proper to write the words. You should always be using the symbols. And also remember, work done is equal to energy transferred. When you're taking your notes down, remember, if it's white, you write. So you really should have all of this taken down. Now let's try applying this to a simple question. So if the force is equal to 20 newtons and distance 10 meters, what is the work done? So the first thing I do is I'd read the question like I just did and underline the quantities I have. So I know that force is equal to 20 newtons and distance is equal to 10 meters. Now I'm going to circle the quantity I need to calculate, which in this case is work done. My next step is I'm going to write my equation. So work done, or work, it can be used interchangeably, is equal to force times distance. Then I'm going to substitute my values from my equation, or from my question rather, into my equation here. So I know that distance is there, 10 meters, and my force is equal to 20 newtons. So let me write that in. My force is equal to 20 newtons, and my distance is equal to 10 meters. And that's equal to my work done, which can be represented using W. Remember, we don't know work done yet. Then we put this into the calculator, and we will get the value 200. A very common mistake is to just leave this answer the way it is. But that's not quite right. Remember, if we go back a slide, work done or work is measured in joules, so we can't forget the unit. 200 joules. And that's a perfect answer.